Good afternoon all. So this is Elkumar from SMS Class Technology and Department of Computer Science Engineering. So now I am telling about scheduling criteria in operating system. So CPU scheduling criteria. So the single process system. So one process can run at a time. So multiprocessing means maximizing CPU utilization. So multiple processors in the ready queue are allowed to utilize the CPU time. So if you are running a process engaged with input output or waiting for a resource, so the next operations will be allocated to the CPU. So basic concept of these scheduling criteria. So maximum CPU utilization is obtained with the multiprogramming, and CPU input and input output or a burst cycle process execution consists of cycle of CPU execution and input output wait time. CPU burst followed by a input output burst, and the CPU burst distribution is a main concern. So in the right side we have a CPU burst and input burst, and wait for input output and wait for input output, and store increment index write to be file, and load store and add store and read from file, and store increment index write to file, and load store and store read from file. Likewise, CPU scheduler. So we have a short term scheduler select from among the process in a ready queue, so and allocate the CPU to one of them. So queue may be ordered in various way. So CPU scheduling decisions may take places when a process, so like switches from running to waiting state, and switches from running to steady state, and switches from running to ready state, and terminates. So scheduling under 1 and 4 is non-preemptive, so all other scheduling is preemptive. So consider access to shared data, and consider preemption while in a kernel mode. So consider interrupts occurring during crucial OS activities. Consider interrupts occurring during crucial OS activities. Dispatcher. So dispatcher module gives control of the CPU to the process and selected by the short-term scheduler, and also it involves switching context and switching to user mode, and jumping to the proper location in the user program to restart the programs, and like a dispatcher latency. So the time it takes for the dispatcher to stop one process and start another running. So it is mainly used in a Windows system and a phone. So the dispatcher is very useful to occur the await the threads. So it will point to the particular process and execute and to the user mode, and it will complete, and after that give the guest mode. So it will take more time to it will not take more time to complete it. So that is the dispatcher scheduling criteria. So first one, CPU utilization, second one, throughput, and a turnaround time, and a waiting time, and response time. CPU utilization means it keep the CPU as busy as possible. Second one, throughput. So it is a process of that complete their execution per time unit. And then the third one, turnaround time. So amount of time to execute a particular process. So it means a process consists of 5 minutes to complete the 5 minutes to complete process, means the turnaround time is 5. So waiting time is the next amount of time a process has been waiting in the ready queue, because it is a new process going to start again. So that process will wait in the new process. For example, I completed one process at a time of 5, so next process will start the time of 6. The second process waiting time is 5. So last one, response time. So amount of time it takes from when a request was submitted until the first response is produced. So no output or time is starving the environment. CPU utilization. So we want to keep the CPU as busy as possible. So conceptually, the CPU utilization can range from 0 to 100% in a real system. So it should range from 40% for a lightly loaded system, so to 90% for a heavily loaded system. So throughput means if the CPU is busy executing process, then work is being done. So one measure of work is the number of process that are completed per time unit, called throughput. So for long process, this rate may be one process per hour. For a short transaction, so it may be the processor per second. Turnaround time. So from the point of view of particular process, the important criterion is how long it takes to execute that process. The interval from the time of submission of a process to the time of completion is the turnaround time. So turnaround time is the sum of the periods spent waiting to get into memory. So waiting in the ready queue, execution on the CPU, and the doing input output. So waiting time, the CPU scheduling algorithm does not affect the amount of time during which a process execute, or does the input output it affect the, if it affects it. So only the amount of time that the process spends waiting in the ready queue. So waiting time is the sum of the periods spent waiting in the ready queue. Response time. So in an interactive system, turnaround time may not the best criteria. So often a process can produce some after output fairly early and can continue computing new results. So while previous results are being output to the user, there's another measures is the time from the submission of a request until the first response is produced. So this measure is called response time. So the time is take to start responding, not the time so takes to output the response. The turnaround time is generally limited by the speed of the output devices. So scheduling algorithm automation criteria: maximum CPU utilization, maximum throughput, and maximum turnaround time, maximum waiting time, and maximum response time. So these are the criteria, scheduling criteria in OS operating system. Thank you.